Hello, hi everyone. My name is Chaitanya. I'm studying in Sri Venkateswara College of Engineering, Department of Electronics and Communication Engineering. Today I'm going to explain the seminar presentation on Bluwark of framework to store IoT data in user account under the guidance of Professor Divakaram, Assistant Professor, Department of Electronics and Communication Engineering, SVCE, Bengaluru. Contents: Introduction, Literature Survey, Methodology, Result, Applications, Conclusion, Reference. Introduction. Data privacy has received a lot of attention recently, driven by the explosion of new areas of data generation and aggregation. Customized devices such as Siri and Alexa directly couple home automation and home security to their respective manufacturers. Even through personal data was subscribed from the applications and the generated maps, the location data contained in the running route independently relied to locations of secret military bases. The device is executing a closed source solution which brokes data between the mobile application and the cloud. It is projected that more than 10 billion devices will be internet connected by 2025. Literature survey. Author and paper title: M.H. Mahazar and Z. Characterizing Smart Home IoT Traffic in the Wild in Professor of IEEE ACM's 5th int Confidential Internet Things Designing Implemented. Proposed work. Here author's proposed work involves collecting that data from various smart home IoT devices such as smart TVs and smart thermostats, smart lights and smart security systems. Future scope. The insights gained from their study can be used to enhance the security, privacy and of efficiency of smart home networks. Author and paper title: Pascu Mohattig, H. Gaharkhi, A. Vishwanath, S.S. Khan here and V. Shivaraman. Evaluating emergency evacuation events using building Wi-Fi data in PROC IEEE ACM 5th Internet Things Design Implementation. Here the authors focused on evaluating emergency evacuation events using building Wi-Fi data. The goal of the study is to use Wi-Fi signals to track the movements of individuals during emergency evacuation events such as fires or earthquakes. The research can help emergency responses to improve their responses timers decisions making during an emergency. Methodology. Comparison of default and Bluwark environmental of the IoT may be optional depending on the device and cloud platform being used. Some IoT devices may be able to send data directly to the cloud platform. The cloud platform may have additional layer for security, data processing and analytics. And IoT devices incorporate of manufacturer owned cloud based back-end support process and store the generated data while simultaneously sharing with third parties. The cloud platform that the framework will use in essential aspects to the design. The cloud platform should offer reliable storage, high availability and scalability. The device executes its own firmware and in instance of the framework. Within the framework, we executed cloud telemetry and instance of the authentication and rules engine, and in some cases of cloud OS. Communication between the device and the two counterpoints will continue pass through the framework. The mobile application contains the command and control and telemetry and rules panels. Command and control exposes user interfaces, objects for device control, and the cases of smart switch and the panel contains toggle switch and user interface power button. The switch toggles power and the user interface button lights upon power activation. In cloud services representation, the remote compute and storage engine and it's deployed as a signal instance per cloud account. To clarify this work and highlight our challenges, we will introduce an example implementation based on Terraform and Amazon Web Series. This is the flow diagram. First we see here user authentication, data ingestion, data processing, data encryption, data storage, data access, data analytics, data sharing. Flow diagram. About the flow diagram, to authenticate of the user and ensure the other authorized to access their account. This can be done using a login system with a unique username and password or any other authentication machine supported by the framework. To ingest the IoT data from various sources such as sensors, devices or other systems. This can be done using APIs or other data ingestion mechanism supported by the framework. Users should be able to share their stored data with other users or systems if required. This can be done using APIs or other data sharing machines supported by the framework. Result: when the user account based approach, user have greater control and ownership over their IoT data. They can manage their data, decide how to store and use it, and choose whether to share it or not. By storing data in user accounts, IoT platforms can offer personalized insights to individual users. These insights can help users understand the performance of their IoT devices and make data driven decisions based on their unique needs and requirements. And this is a smart plug, and this is smart scale of the truth tables.